Welcome to this highlight video for the latest features in CUDA developer tools. With these latest releases, we've added several new features to give you more visibility into your system's performance and detailed information about your usage of the latest CUDA enhancements. Nsight Systems 2021.2 introduces support for GPU metric sampling and tracing of CUDA unified memory page faults on the CPU and GPU. The GPU metric sampling feature allows you to view and analyze low-level utilization details on a timeline. These provide a system-wide overview of efficiency for your GPU workloads. They include metrics on I/O activity, including throughput for PCIe, NVLink, and DRAM. They also show SM utilization, tensor core activity, instructions issued, warp occupancy, and unallocated warp slots. This new metric sampling expands Nsight Systems' ability to profile system activity and help track GPU workloads and their CPU origins. By providing a deeper understanding of the GPU utilization, it helps answer fundamental developer questions such as, is the GPU active most of the time? Are the kernel grids large enough, or is there enough work in parallel streams to occupy the available SMs and their warp scheduling slots? Is the SM instruction rate high? Are tensor cores being used? Can I see GPU direct RDMA or GPU direct storage transfers? These metrics cover multiple processes and contexts, including graphics and compute workloads with CUDA, optics, DirectX, and Vulkan ray tracing and rasterization APIs. Nsight Compute is the premier profiler for detailed analysis of CUDA kernels. As such, it's important that it can understand and profile the latest CUDA features. The first feature allows us to track the newly introduced CUDA user objects in the resource tracker. User objects are a helper construct to conveniently manage host-sided resources in CUDA graphs. They can be used to link the lifetime of resources to the lifetime of the graphs that reference these resources. CUDA will automatically manage their lifetime with reference counts and destructor pointers for cleanup. To track user objects, run an interactive profile and open the resource tracker. Select User Objects from the dropdown. This application allocates a user object and increases the reference count by 10 to keep track of multiple live references. When the reference count eventually reaches 0 as the final handle is released, the object is automatically destroyed. This real-time tracking will help you understand your memory usage and identify leaks or missed deallocations. On a similar note to user objects, asynchronous allocations from the recently released stream-ordered CUDA memory allocator can also be tracked in the resource tracker. Asynchronous allocations draw from memory pools that can reuse chunks of device memory without needing to go through costly system calls. They can be a big boost in performance for applications with lots of memory allocation and deallocation. The Nsight Compute resource tracker seen here has memory allocations selected from the dropdown while running an interactive profile. We see all of the allocations listed here, their sizes, and now some new information about memory pools. If this is the first allocation from a pool, we see Request New Allocation as the allocation mode. But after the application freed some memory in this pool and allocates again from the same pool, we see a different reuse mode listed. This means the application is avoiding another system allocation and reusing an existing pool. By maximizing your memory pool usage, you can improve performance by avoiding system allocation overhead. Additionally, in the memory pools dropdown, we can see properties of the current pools. Information like reserved size, used size, and the high usage watermark can inform your decisions about whether you're using memory pools efficiently. The third new capability is tracking of dynamically created CUDA graph nodes during stream captures. Stream capture is a CUDA feature that provides a mechanism to create a graph from existing stream-based APIs. Recently, CUDA added support for modifying these graphs via APIs while they are being captured. In the graph node dropdown, we can see the nodes of a graph as it's being constructed using stream capture. At this point, an API is called to add another node to the currently under construction graph, and Nsight Compute will track it just like any other node. CUDA graphs are an efficient way to express dependencies between CUDA kernels and allow the runtime to dynamically schedule work in parallel as dependencies are checked and met. Nsight Compute can even export the resulting graph as an image to give you a visualization of the kernel dependencies in your code. In order to fix a performance problem, you need to see it first. All of these new capabilities in our Nsight tools help you do exactly that. Whether it's at the platform level with Nsight Systems or deep inside a CUDA kernel with Nsight Compute, Visualizing how your workload is using hardware and software resources gives you a better understanding of how to focus your optimization efforts. You can find all the latest details about our developer tools on their respective web pages and more information in the video description below. Thanks for watching.